Students, in our last lecture we have studied the rules of derivatives of standard inverse trigonometric functions. Today in this lecture we will solve some examples related to those rules. Okay, so in derivatives of an inverse trigonometric function. So let us recall all those rules. See here in this table, functions and their derivatives. Number 1, y is equal to sine inverse x. Then the dy by dx means derivative of sine inverse x with respect to x is equal to 1 upon root of 1 minus x square. Okay. Second one, y is equal to cos inverse x. Then its dy by dx is minus 1 upon root of 1 minus x square. Then third one, y is equal to tan inverse x. Then its derivative is 1 upon 1 plus x square. Fourth one, if y is equal to cot inverse x, then dy by dx is equal to minus 1 upon 1 plus x square. Fifth one, y is equal to sec inverse x, then dy by dx is equal to 1 upon x into root of x square minus 1. Here in case of sec inverse x, you know that as sec inverse x is an increasing function, so the dy by dx is always positive. Okay, so here the derivative is 1 upon x into root of x square minus 1. And last one, if y is equal to cosec inverse x, then its derivative is minus 1 upon x into root of x square minus 1. Why it is minus? Because cosec inverse x, this function means graph of this function is always decreasing. So remember, in case of sec inverse x, we have to take 1 upon x into root of x square minus 1, and in case of cosec inverse x, we have to write the derivative as minus 1 upon x into root of x square minus 1. So all the results are proved in our last lecture. Okay. Now today we will solve some examples related to this all these rules. Okay. So again see carefully all these rules. You have to remember this as a formula. Okay. So let us solve some examples. So find dy by dx. First example, y is equal to sine inverse 2x. Now see, this is the composite function. You know how to find out the derivative of composite function. Here the inverse function is included, inverse trigonometric function is included. So we need that rule, that is derivative of sine inverse x. We know the derivative of sine inverse x is 1 upon root of 1 minus x square. Now see, if you want to differentiate this with respect to x, then see here dy by dx is equal to, we get 1 upon root of 1 minus 2x square into d by dx of 2x. Here in place of x there is 2x, so the chain rule is applicable. Okay, so by the standard inverse functions derivative we get this derivative, and by applying chain rule, that is d by dx of 2x. So further we get this 1 upon root of 1 minus 2x square into 2. Into 2 means it is the derivative of 2x. So hence the answer is 2 upon root of 1 minus 4x square. This 2x bracket square can be written as 4x square. So this is just answer of this. Okay, so remember the rule of derivative of sine inverse x, then you will get the answer like this, 2 upon root of 1 minus 4x square. Okay, very simple. Now next one, suppose it is given that y is equal to tan inverse log x. Now this is tan inverse function. Original function is tan inverse x. You know the derivative of tan inverse x is 1 upon 1 plus x square. Now in place of x there is log x. So see how will you differentiate this with respect to x. So dy by dx is equal to, see here, 1 upon 1 plus log x bracket square into d by dx of log x. See here again chain rule is applicable. So see here carefully. So what will be the next step? This is the answer. That is 1 upon 1 plus log x bracket square, keep as it is. Okay, into log x, derivative of log x is 1 upon x. You can keep this as a final answer. Okay, 1 upon 1 plus log x bracket square into 1 upon x. This is just the answer of this derivative. Okay. Now third one, if y is equal to cos inverse of x raised to 3 by 2. See here, x raised to 3 by 2. Original function is cos inverse x. And here it is cos inverse of x raised to 3 by 2. So differentiate with respect to x. So see here dy by dx, as we know that derivative of cos inverse x, original standard function, derivative of cos inverse x is minus 1 upon root of 1 minus x square. So here how will you write it? Here in this case it is minus 1 upon under root 1 minus, now in place of x there is x raised to 3 by 2, remember. So x raised to 3 by 2 bracket square into d by dx of x raised to 3 by 2. This is by chain rule. See here again properly, minus 1 upon under root 1 minus in bracket x raised to 3 by 2 square, in place of x there is x raised to 3 by 2. So x raised to 3 by 2 bracket square into d by dx of x raised to 3 by 2. This is by chain rule. So by simplifying this we get minus 1 upon under root, see here 1 minus, now x raised to 3 by 2 raised to 2 means it is just x cube, see here, into what is the derivative of x raised to 3 by 2, see here, it is 3 by 2 into x raised to 3 by 2 minus 1. 3 by 2 minus 1 we get 1 by 2. Okay, so you can write the final answer like this, minus 3 upon 2 into root of 1 minus x cube into root x. Root x means x raised to 1 by 2. So you can write this as a final answer. Then fourth one, see, if the function is given y is equal to tan inverse 2 raised to x, y is equal to tan inverse 2 raised to x. Again here tan inverse x function, original function is tan inverse x. So the derivative is 1 upon 1 plus x square. So if we differentiate this with respect to x, here in place of x there is 2 raised to x. So how will you differentiate? See here, it is 1 upon 1 plus 2 raised to x bracket square into d by dx of 2 raised to x. See here, in place of x there is 2 raised to x. So 1 upon 1 plus 2 raised to x bracket square into d by dx of 2 raised to x. This is by chain rule. Then next step will be 1 upon 1 plus 2 raised to x bracket square into the derivative of 2 raised to x. You know that it is 2 raised to x into log 2. and hence we get the answer 2 raised to x log 2 divided by 1 plus 4 raised to x. 2 raised to x bracket square can be written as 4 raised to x. So these are the 4 examples that we have discussed today. Okay, very simple, related to all that standard formulae. Okay, so homework is there for you. See, find dy by dx. Here it is given that y is equal to cot inverse x cube. See here, cot inverse function is given. Try to differentiate this. Okay, cot inverse x cube, in place of x there is x cube. Okay, then next one is y is equal to sine inverse of 1 minus x square. Original function is sine inverse x. In place of x there is 1 minus x square. Okay, so try this. And third one is y is equal to cosec inverse of e raised to minus x. Original function is cosec inverse x. You know the derivative of cosec inverse x. So here it is composite function cosec inverse of e raised to minus x. In place of x there is e raised to minus x. So if you remember all those standard rules, then you can differentiate this with respect to x. So try this as a homework. Okay, thank you.